In a discussion about marginal utility, we realize that because we are unable to measure utility, the derivation of the demand curve from that theory may not realistically hold true, because in reality, we are not able to measure utility of any individual. An alternative explanation of consumer behavior, which attempts to overcome some of these difficulties that we have encountered in the marginal utility theory, is that of indifference curve analysis. Now, indifference curve analysis is based on this assumption that although we may not be able to measure exactly how much utility or satisfaction we get when we buy a good or service or a combination of good or service, it is possible, however, to conclude whether we as individuals obtain more or less satisfaction from one product or another. In other words, we can do ranking. Like, for example, I can tell you I like apples more than bananas or bananas more than oranges, but I can't tell you by how much. This ranking, therefore, can help us now make a scale of preferences. For example, if a ticket for a soccer match has the same price as one for a rugby match, and the individual chooses to go to the soccer match, we can reasonably assume that the individual prefers to go to soccer match rather than rugby, and therefore he ranks soccer higher than rugby. This analysis goes on to argue that we can, from this ranking, identify different combination of two goods between which an individual has no preferences at all. That is, he is indifferent when it comes to those combinations of goods. And from that, we can actually make a whole map of his preferences. The aim, therefore, of the indifference curve analysis is to analyze, without having to measure utility, how a rational consumer chooses between, let's say, two goods. Let's understand this more through an example. So, let's say I have an individual who is basically thinking about two goods, apples and oranges. So, he is going to find out a combination of apple and oranges, which can result in maximum possible satisfaction from his limited income. For that, we now need to find out all the different combinations of two goods between which this individual, let's say Ali, has no preference at all, or he is indifferent. So, for example, if I tell you, if you give him a combination of 40 and 1 and then reduce the amount of apples from 40 to 30, he will say to you, in order to make me indifferent, that is, give me the same satisfaction that I get from 40 of apples and 1 orange, is that you give me 30 apples and 2 orange. And it makes sense, because when you reduce your amount of apples by 10, he may want to be compensated by an extra orange in order to make sure he remains indifferent. Otherwise, if you give him, let's say, 30 apples and 1 orange, then he will say that, 40 and 1 is better than 30 and 1, and therefore he may not be indifferent. But in order for us to have him indifferent, that is, have the same utility, and by the way, we don't know what utility it is, but we are assuming that they give you the same, let's say, unspecified utility, or you rank these combination equal. Similarly, if I reduce the amount of apples from, let's say, 30 to 22, right? This will mean, again, he will be like, you know what, you've reduced the amount of apples by 8. Now I want you to give me one more orange in order for me to be indifferent between these combinations. So we can call these combination A, B, and C. So right now I'm saying he is indifferent, or he has the same utility for combination A, B, and C, because every time you reduce the amount of apples, you compensate him with an extra orange, and that is making him indifferent. So we can use this knowledge and make a whole sort of map for this individual. And let's say we come up with these combinations that are here, where you could have a combination D where you are getting 17 apples, but then you're also getting 4 oranges, and 17 and 4 is equal to 22 and 3, and vice versa. 17 and 4 is equal to 13 and 5. So all of these combination, I am basically able to figure out this individual's sort of indifference map, where he is indifferent in terms of any combination because they're giving him the same satisfaction. So from this table, we can draw now the indifference curve for this individual, which simply shows all the various combinations of two goods that give an equal amount of satisfaction to this consumer. Let's say on my y-axis I have apples, and on my x-axis I have oranges. So we can look at the values, where one value was, for example, 40 and 1. Another value, for example, was 30 and 2. If you go back to the table, you had these values of 30 and 2. And then we had 22 and 3, and so on and so forth. So we can sort of plot these values and are able to what we call draw our indifference curve analysis. When I plot these values, you will find out, for example, number one, this curve turns out to be what we call a downward sloping graph. As you get more and more of oranges, you will get less and less of apples. In other words, if the consumer is moving from, let's say, A to B to C, he is choosing less and less of apples. And in order to compensate him, in order to make sure that his satisfaction is same for combination A and B, he needs to be compensated by giving more and more of oranges. And that suggests to us that there is a trade-off here, because more of oranges means less of apples, and vice versa. Less apples for him have to be compensated by more of oranges. And we do this primarily because we assume that the satisfaction or utility is the same on the indifference curve. So anytime I move from A to B, I get less of apples, but I get more of oranges, and this makes my utility along the indifference curve to be the same. Now, the slope of the indifference curve is also known as the marginal rate of substitution. This slope tells us the rate at which the consumer is willing to exchange one good for the other, keeping his or her satisfaction the same. So for example, if I move from point A to B, I know this, that the consumer is giving up 10 of apples for one of orange, which means if I find out the slope of this point, it will be change in y over change in x, which is going to be minus 10 over 1 or minus 10. Now this minus 10 means that the marginal rate of substitution is minus 10, which means for 10 apples that he sacrifices, he is requiring one orange to compensate for this loss. Similarly, when I go from B to C, my marginal rate of substitution becomes minus 8. As for now, every one orange that I get, I lose 8 of apples, so my marginal rate of substitution is minus 8. And similarly here, when I go from C to D, the value is going from 22 to 17, which means it's a minus 5, and therefore my marginal rate of substitution now will be minus 5. Now, minus basically means that the graph is downward sloping, which simply means that more of oranges are needed to compensate for the loss of apples. That's one thing. But also, one more thing that we notice is that as we move down the curve, the marginal rate of substitution is going down from minus 10, for example, to minus 8 to minus 5. So what do we mean by diminishing marginal rate of substitution? This marginal rate of substitution or diminishing marginal rate of substitution is simply based on our principle of diminishing marginal utility that we did earlier. As I am getting more and more of oranges, I can clearly say this, that the utility of each additional orange will be going down, and therefore each additional orange in terms of apples will have a lower value. So for example, for the first orange, I was basically asking for compensated for 10 apples, but the second one was compensating only for 8, which means the value of the second has gone down in terms of apples to 8, and that suggests to us a declining or a diminishing marginal rate of substitution, primarily because of the law of diminishing marginal utility, which simply states as quantity rises, marginal utility falls, and therefore the value you place on the good falls. And that's why here the value has fallen in terms of apples for every one orange from -10 to -8 to -5. Another way to look at marginal rate of substitution is this idea that when I am looking at this point A and I go from point A to B, I get one additional orange by losing 10 apples. In other words, I can say this, that the utility that I sacrifice by giving up 10 apples is equal to the utility I get from getting one orange. In other words, marginal utility of an orange must be 10 times marginal utility of an apple. So I can write this, that MUO, the marginal utility of an orange, is equal to 10 times the marginal utility of apples. And if I rewrite this, I can say it as MUO over MUA is equal to 10. Now, this is exactly the value that we found for marginal rate of substitution. If you remember, the marginal rate of substitution was simply the slope, which is change in y over change in x, and we said that the marginal rate of substitution will be -10 over +1, or in other words, it will be -10. So one could argue this MUO over MUA is also equal to the marginal rate of substitution. So in other words, we have found a general form for marginal rate of substitution in terms of utility, and that is the utility of oranges over mu of apples. And if I want to write this in general form, because oranges is on the x-axis and apples are on the y-axis, I can rewrite this and I can say the marginal rate of substitution, or in other words the slope of the indifference curve, is simply mu of x over mu of y.
If you like the content you just saw and all the other content that is on my website, then you need to head over to allacademy.org, where you will find more content not only of my subject but also 5 other subjects. So go there.